So that's why there was no class yesterday. Okay, so what are the answers for the previous problem? So different processes, 3 work done should be there. This is the first process, which is polytropic work done. Second process isobaric, third process isochoric. So 3 work dones I need, and I should add those 3 to get my final answer. So what are the answers for it? Ramdas? Ramdas. Shravan Pujari? Ashwita?
So, not sure.
Hmm.
Um,
Give your
the
answers,
first
no
one,
problem.
work 1 to
Hmm.
2, 5 into 10 power 4.
So it's 5 into 10 to the power of 4. Okay.
Work W two 3 is minus 2.5 into 10 power 3.
Minus 2.5 into 10 power 3. Yes.
And the next one would be 0.
Why it is 0, Ashwita?
So since it's a horizontal line, there's no work, there's no area or slope. So there's no work done. It's an isochoric process.
That's great. Correct. Yes. Any other answers, guys? Good, Ashwita. Any other answers?
So work done from 2 to 3 is 25 minus 25 kilojoule.
Okay, minus 25 kilojoules. It's not 2.5. Okay. That is.
Rest is fine, sir.
Okay. Rest is fine. So I can write this particular thing. Shall I change this as 50 into 10 to the power of 3 so that it will be
Yes.
convenient? Okay, I can write this as 50 kilojoules of work, which is positive, and this as minus 25 kilojoules of work, which is negative. And 3 to 1 is 0 because it is an isochoric process. Okay. Now, if I want to calculate net work done, how much it would be?
It's 25
50
kilojoule.
minus 25. So it's 25 kilojoules. That's the exact answer. Very good. Okay. So any doubts in this problem? Whether it was easy after solving so many? Are you able to
Easy,
get
sir.
the concepts? Okay, fine. So today we will start some of the different problems which will not be whether there is a no mention of isochoric, isobaric or any other process in such problems. These are peculiar kind of problems which are even asked in your previous question paper. So I've just sorted out few of them from the textbook. Okay, we shall try to solve this. See, this is the kind of the problem which I have stated. A quasi-static process occurs such that P is equals where T is the pressure in bar and B is the volume in meter cube. Find the work done when the volume changes from 1 meter cube to 3 meter cube. Simple problem. It has been asked for 9 marks in your previous examination. 9 marks. Unbelievable for this. So how do you have to solve this? Just go with the basics of the work done, displacement work. Okay. What does it say? Work done from 1 to 2 is equals to integration from 1 to 2 P into dV, correct? So here he has given the value of P, that is V square plus 8 by V. Just substitute integration from 1 to 2, the value of P being V square plus 8 by V dV. Okay. Now integrate this and give me the final expression. Let me see how many of you could integrate this particular expression with respect to V. Yes, integrate it. So integrate for both things, that is integration from 1 to 2 v square plus integration 1 to 2 8 by v dv. Okay. Further, what is integration of v square? That is x to the power of n, nothing but,
Power 3
yes.
X
Okay.
cube by
What it
3.
is?
by
X power
So
n
what are
divided
you,
by x power n plus 1.
x to the power of n plus 1
x
divided
power
by
n
n
plus
plus 1.
1
That is the integration of
n
x to the
plus
power of n. Similarly, if you go for v square, what it would be? It would be v plus, if you take 8 outside, what would be? Integration of 1 by v. Integration of 1 by v is what? Excellent. So it is just,
log
I can take it
log
as
of
ln
v.
of v. Okay. So it is, just a minute. It is ln of v over the limits 1 and 2. Okay. If you further substitute the limits, what it would be, so I'll just take the constant out, 1 by 3. It is v2 cube, v2 cube minus v1 cube plus 8 into, again, ln of v2 minus ln of v1. In the problem, he has clearly specified what is the value of v2 and what is the value of v1 as initial and final volumes. Okay, so initial volume meter cube and final volume being 3 meter cube. Just substitute the things 1 by 3 into v2 is 3 cube minus 1 cube plus 8 into ln of 3 minus ln of 1. So that gives your work done from 1 to 2, I guess. Give me the value. Yes, what's the value? .8 was, okay, 7.8. That's it. Kilojoules or joules, what it is. So this is the answer given by Muaz. Just check others got the same value or not.
Is it
Okay,
17.4?
information. Karthik, yes,
45.
17.45. So just check the answer given by the Karthik, whether it's right or wrong. Okay, in and around
17.39.
the same, right? Decimals. 17.45, since majority of getting the same answer. Okay, so such a simple problem, just an integration of that particular given expression will fetch you 9 marks for the examination. Okay, this was very easy problem which was given. Okay, so done. Shall we move to the next? Okay, just take this problem. It's been taken from your question paper, which is thermal engineering question paper. Okay, take this problem. Compute the work done by 1 kg of fluid system as it expands slowly behind the piston from initial pressure. So initial pressure is given as 6 into 10 to the power of 5 Pascal, that is 6 bar, and initial volume of 0.06 meter cube to a final volume of 0.18 meter cube in the following processes. So he has given 3 different processes. So number 1 is the pressure remains constant. So which process, if pressure remains constant? Guys, which process?
Isobaric.
So it's isobaric process. Okay. Second process is the volume remains constant. So which process?
Isochoric.
Isochoric. And the third process, PV to the power of 1.3 is equals to constant. So it is polytropic. Okay. You need to calculate the work done for this and for this and this. So this I can write straight away as 0 without any calculations, right? For an isochoric, the work done. So he has asked us to calculate the work done. Is it directly I can write it as straight away 0. So if you calculate what is the work done in an isobaric process, that is given by what? P into V2 minus V1, work done from 1 to 2. Okay, if you calculate using this, and for the polytropic, just an expression 1 to 2, which is given by P1 V1 minus P2 V2 divided by n minus n. If you calculate this, you will get 8 marks straight away. Okay, so just copy this problem and try on it around. Okay, if you have any doubt, you can just let me know. This was a very latest question paper, 2019, I guess. Abdul Rahiman, Abhinav, Ashanul Mustafa,
It's
Abhinav.
sir, Abhinav, sir.
Next is Ashanul Muhammad Reza. Next is Akshay Arkutian, Amit Islahari, Amrut, Anbeth, Ashwin, Ashvita,
Present, sir.
Present, sir. Anvit.
Anvit C.
Abdurrahman present, sir.
Who is this? Reza. Where were you guys when I called your name? Is okay. Abdul Rahiman. Binoy, Fahad,
Sir,
Faisal,
you didn't call
Present,
Chandan.
sir. Benoy present.
Chal. Binoy present. Okay.
Sir, Chandan.
Just a minute, Chandan. I have called your name. Man. Okay. Marked you, marked you. Next is Fahad, Faizan, Amit Lahari. Okay. Faizan.
Present, sir.
Amit Lahari, yes, ma'am. I marked you. Faizan, Gaurav, Gaurav, Gautam,
Yes, sir.
Javel.
Present, sir.
Next is M. Karthik,
Present, sir.
Fazil, Muhammad Sihab.
Present, sir.
So, okay. So how many of you say, just by looking at the problem, this particular problem, 8, I guess, yes, it is 8. So how many of you say I can do it, sir, without any help?
We can, sir.
So whoever feels I can do it, just message me in the chat box. Or if anyone having the problem in solving this, even that you can post it. Do it fast, please. I'll move to the next problem. Okay. What about remaining then? Make it fast, make it fast. We have to end this module today, so. Okay. Okay, so majority of people are feeling that they can solve it, and I'm happy for you all, you guys, that you can solve it. Okay, next we shall go to the one typical example of mechanical work done. Just take this. The fluid, this is the ninth problem, and you have to solve this in the notes. Once this module completes today, I will try maximum to complete this by today. So once this module gets completed, you have to submit your notes along with your assignment one, which will be given to you, okay, in the Google Classroom. Okay, I'll be raising the assignment over there. Coming to this problem, the fluid is contained in a cylinder which has a stirring device turning at 850 RPM. So there is a cylinder like this. Okay, there is a cylinder. Just draw a box. Okay. In this cylinder, what happens? There is a stirring device. In the sense, there is an device which is used to stir it. Okay, which is used to stir it. Okay, this rotates at how much? 8,500 RPMs. That is the speed of this particular thing, with an average torque. Torque also meter. So this is actually piston and cylinder arrangement. Okay. Like this. So it's a piston and cylinder arrangement like this. Okay. Now torque is given. The piston is frictionless because there is no friction between the surface of the cylinder and the piston, so there is no friction. Okay, is held against the fluid due to atmospheric pressure. So this particular piston here is held against the atmospheric pressure like this. So whatever the opposite pressure is acting, that is your atmospheric pressure, P atmosphere, equal to, that is values also given. So it is 100 kPa. That's 100 kPa. The piston diameter, so diameter of the piston is being given. So diameter of the piston is how much? 50 centimeters. So 50 centimeters. Okay. If it moves outward by 65 centimeters, what does he say? In the sense, the piston is moving and outward in this direction. Okay. For how much? 65 centimeters. So about 65 centimeters, the piston is moving outward. Okay, determine the net work transfer for the system. So meanwhile, take the question as well as the little representation of the diagram. Okay, and just intimate me once you have done. Was okay, Tausif Ali, Muaz.
Present, sir.
Next is Sumit and Suraj. Nafa, Namita Nair,
So she has
Mandish.
indicated this.
Okay, tell her to message me, okay, or give me an intimation so that I can mark. Mandish, Nartan,
Present, sir.
Niharika. Okay, next is Nishchit. Nitin George has this thing. Okay, fine. Nartan have marked you. Next is Omkar. Prarthan. Pratish Varnam. Prajit.
Present, sir.
Akshan. Prajit. Okay. Rakshan. Okay, Rakshan is having this thing, I guess. Today. Ramdas.
Yes, sir.
Ranjit. Ramdas is there. Okay. Ranjit. Ranjit, Shabit. Just writing info text. Okay, those who are the students who are writing Ashwita, the Infosys test, just ask them to just give me a message in the WhatsApp or in the email also. Okay, then I'll definitely mark them. Next is Sagar,
He's also having test, sir.
Shahzad.
Present, sir.
Okay, Shahzad.
Present, sir.
Okay, Shashank, Shetty Sujay,
Present, sir.
Shetty Tejas.
Present, sir.
Okay, next is Sujay. Okay, Tejas. Okay, Shravan,
Present, sir. Shujay.
Shravan Kumar. Sujay Shetty, I have marked you, man. Shravan Kumar, Sriraj, Saurabha,
Present, sir.
Sumant, Saurabha. Okay, Sumant, Varun, Vigneshwara, Amit Sangoli,
Yes, sir.
Inglesh Merkel,
Present, sir.
Prajwal Hegde, Sandesh, and Rachan. So many of the students are still not returning their first class. What's the reason? Rohan Pradeep, Varun,
Present, sir.
Adarsh P,
Yes, sir.
Rohan Pradeep. Okay. Adarsh P. Okay. Sampreet, Muhammad Amin, and Zaman Asadi. Okay. So, how many of you have attended the Infosys test? How many of you have attended Infosys? Okay, fine. So, how was the paper? Whether it was easy, tough, on which segment it has a more focus? I just want a review of that. How was the paper? Pseudocode was difficult. Okay. Apart from that, time management, that's true. That's why you have to attend more and more mock tests before to that. Okay, many online tests also will be there. So attend those. Time management is a very important segment in cracking all the placement papers. Okay. I heard the overall setting was moderate and all with respect to the branches also. Apart from that, quite good. So time is a factor. Okay. So we shall come back to this particular problem here. So he says, where is the system? The system is here. Okay. Which contains the fluid, which I'm highlighting right now, is the system. Okay. In the system, there are two works performing simultaneously, correct? There are two works. The number one is using an agitator. Sriraj, I have marked you, man. Sriraj. Okay. So using an agitator, you are giving work input to the system. You are working on the system. Okay, that is one work. And because some amount of the work is being engulfed into the system, okay, it pushes the piston against the atmospheric pressure. So it moves around 65 centimeters. That means there is work done by the system. Okay, there are two works. Number one is you're working on the system using an agitator. The second one is by the system, there is a movement of the piston. This is work done by the system. So I can just say this as W1 and this as W2. Okay. So for an instance, I will write let W1 be work done on the system using agitator, what he has specified, stirring device. Okay, so just use whatever he has specified. Okay, work done on the system using a stirring device. Okay, let W1 be that particular work. Next, W2 is be the work done by the system by moving the piston against atmospheric pressure. Okay, so this is the W1 and W2. You are supposed to calculate what is the question. What is the question? Determine the net work done. Determine the net work done for the system. So, net work done by the system. Can I write simply it as W1 plus W2? Correct? So, the summation of these two works is your net work done by the system. Now, according to you, without any calculations, can you say which one would be negative and which one would be positive? W1 would be positive or negative? W2 would be positive or negative, according to you? Yes, guys. So which one would be positive and which one would be negative? Or whether both will be positive or both will be negative?
The first one will be negative, sir.
First would be negative. Okay. Why, Karthik? So apart
Because it
from
is
Karthik,
done
I
on
need
the
others to
system.
work done on the system. That's great. Amit Lahari. Amit Lahari. Amit Lahari. Okay, I guess it's not there. Okay. Next, Anvit. Anvit Sirai. Anvit. Okay, not there. Rohan Pradeep. Rohan. Rohan. Not there. Next is Sujay Shetty. Shetty Sujay.
Yeah, sir.
Not there. Okay, Sujay, you are there. So
Yeah.
W1 and W2, both works I have explained to you. According to you, which one is positive and which one is negative and why?
I don't know, sir.
Why man?
Couldn't understand the topic.
Okay, let me check your attendance. Shetty Sujay. Okay, you were absent for many of the classes, right? In the initial,
Yeah, sir.
Sujay.
Yeah, sir.
So just copy the notes very predominantly you copy the notes. That is very important. Okay.
Yeah,
After
sure.
that, we will try to engage once again. So, I've missed the first 10 classes, which are damn important to understand the subject. Again, we will teach once again. We shall look into that. Okay.
Okay.
Next is it's not working. Okay, and we shall see. Just check your audio and make it workable by the next class. Prajat, try.
Yes, sir.
So, which one is positive and which one is negative and why?
So work 2 is positive and work 1 is negative, sir. Negative because
Why?
the
Why? What's the
work is
reason? What's
done.
the reason?
Negative because work is done on the
Work
system.
is done. Okay.
On the system.
Work is done on the system, that's why it is negative. Work is done by the system, that's why it is positive.
Yes, sir.
Very good, Prashant. Okay, we shall start the problem. So first we have to calculate what is the value of W1 and W2, and then you have to club the both the things, is it? So W1 is equals to, so which type of work it is? So it is a shaft work. For that, the formula is 2 pi nt. Okay, just 2 pi nt. If you divide it by 60, you will get it in watts. But if you do not divide it by 60, you will get it in joules. Because watt is nothing but what? Joules per second, is it? So that is how it is. Okay, you can, okay, I'll just keep it like that so that you can understand it. Okay, so watt is equals to joules per second. So if you divide it by 60, whatever you will get in the watts. Okay, when you divide it by nothing, just if you multiply it by 2 pi nt, then whatever the answer you'll get it in joules. So that is how it goes. Okay, so we want in joules, so we shall take the second expression. So W1 is equals to, now what I'm supposed to know, I'm supposed to know for this substitution, N I'm supposed to know. N is given in the problem. Yes, it is given in the problem. It is 8,500 RPM. So it is 8,500 RPM. That's great. Next, torque. What is the value of torque given? 1.75 Newton meter. So both the things are given. Just substitute and give me the value. 2 pi is equals to N is 8,500. Okay, into torque is 1.75 Newton meter. Okay, so the value of W1 would be negative. Keep this in mind. You have to take the value as negative because it is work done, work done on the system.
93.4 kilo.
Okay, 93.4.
Kilo.
Write it neatly. 93.41 something kilo joules. Huh? Okay, joules. So this is your work done number one. Now you have to go for work done two. So work done two is you can just write it here before this. So it is a shaft work. This is a shaft work. Okay. Now work done two is your displacement work. Work done two is your displacement work. Okay. So how do you calculate? So displacement work is given by P into dV, right? It is given by P into dV. And what does dV? Volume, can I write it as area into length? Volume can be written as area into length, thus, correct? So it is nothing but this can be written as area into change in length. I can even write it as PL because, okay. Understood? So volume can be written as area into change in length. Now, pressure of the atmosphere is given, which is 100 into 10 to the power of 3, pressure against which is going. And area can be calculated as pi by 4 d. D is 50 centimeters. So 50 into 10 to the power of minus 2 whole square. So area is done. And change in length is given, that is 65 into 10 to the power of minus 2. I'm substituting all in meters. So just calculate this and give me the value of W2, which would be positive. Which would be positive.
12.76 kilojoule.
How much?
12.76 kilojoule.
12.76 kilojoules. Now my task is to calculate the net work done. So the net work done by the system is W1 plus W2. Okay, so W1 is minus 93.41 plus W2 is plus 12.76. So what is the value? Around 80 something. 80
Minus
something.
80.7.
80.7 kilojoules. That means the net work done by the system is 80.7 kilojoules. Okay, so that is your net work done by the system. Okay, so that is your problem. Simple. Okay. Because you have not done it, you can just copy the things. Okay. So this is a 17th class. So most probably
What does DL mean?
DL in the sense it is change in length, Muvaz. See, initially it was some other length. He says in the question where pick up the pen. In the question, what he says against a fluid and a gravitational diameter, if it moves outward by 65 centimeter, that means it is the change in the length, correct? If I want to calculate the change in the volume, I must multiply area of the cross section with the change in the length. So that is what I've done. So DL is nothing but your 65,
Okay, sir.
by which it has moved. Okay. Okay, I think it would be done. Shall we move to the next, which is very much similar to the present problem? Shall we?
Yes, sir.
So take this problem, the next one. A fluid in a horizontal cylinder fitted with a frictionless leak-proof piston is continuously agitated by means of a stirrer passing through the cylinder cover. The cylinder diameter is 400 mm. During the stirring process of 10 minutes, so he has given the time here for the 10 minutes, the piston moves slowly outward to a distance of 485 mm against the atmospheric pressure. The net work done by the system during the process is 2000 Newton meter. So he has given what? He has given the final answer, which we have calculated for the previous problem. He has given that. So he has given. So he might ask anything else to calculate. Given the speed of the electric motor driving the stirrer is 840 rpm, so yes, given the speed also, estimate the torque, yes. So we have to uh, calculate the torque which is required to drive the shaft. So that is the problem. Similar to the previous one, but there is a reverse approach for this. Okay. Numan, sir, they have marked you, man. I marked you present. Okay. Shall we start solving this? Be ready with the data. Try to plot the same figure which I have plotted for the previous problem. Okay. And indicate all the data in it, whichever is being given. And whenever I ask anyone by particular name, so he must be in a position to answer. So once you have done writing the question, plotting the diagram, indicating all the parameters which are given, just activate. Okay. Done, guys? Shall we start solving this? Oh, Friday is a holiday, right? Okay. Okay, shall we start?
Yes, sir.
Okay. Yes, same thing here. Let me copy this. Yes, what are the parameters given? What are the parameters given for this problem?
RPM is
Shahzad
840.
Abdullah. Okay. Shahzad Abdullah.
Sir.
What are the different parameters given in the problem? Yes, Shahzad. Yeah.
The cylinder diameter is 400 mm.
Okay, cylinder diameter has been given. How much it is? 400 mm. Okay, can I write it as 0.4 meter directly?
Sir.
Next.
The process is 10 minutes.
What else is given? Time he has given as 10 minutes. Okay. Next.
The piston moves a distance of 485 mm. 4.85.
So DL he has given the change in the length. How much?
408.
480 mm. Huh?
Yes, 85 mm.
So, okay, 485 mm. So I can write it as 0.485 meters. Next. What else?
The
So he
network
has
done.
given the atmospheric pressure. Okay,
It
just a minute, Shahzad. Just write this up. So Newton per meter square he has given. He has given network. Okay,
2000
network. So what is that? Network by the system or it is on the system?
by the system.
So it is by the system. So Newton, how much is given? Okay, Newton meter here. Hello. Yes. Why? What's the reason? Who is this first of all? Huh? Option, yes, ma'am. Okay. Keep your Infosys password very safe. Okay. Do not change it or alter it frequently because it gets blocked and it has been faced by many other students. Okay. Yeah. So network done is to 20,000 Newton meters. Okay. Newton meters. Okay. Whether this is by the system or it is on the system. So Newton meters is nothing but joules, guys. Do not get confused. Newton into meter is nothing but joule again. Okay, both mean the same. Yes, whether this is work done by the system or it is work done on the system, whichever been given in the problem. Yes. Ashmita.
By the system, just by the fluid.
So it's by the system. So if it is by the system, okay, whether should I take it positive or should I take it negative?
Positives.
So that's what. So you have to take it positive, and this is the very important step. So if you have to carefully observe this word here, okay, which is written here, whether it is by the system or on the system. Suppose here the word by is replaced with on, then I have to take this as negative value. So be very, very careful about this. Okay. So these are the things that are given. Again, you can write the same thing. Which is this. Okay. Let W1 be the work done on the system using the Stirling device, and W2 be the work done by the system by moving the piston against the atmospheric pressure. So net work done is being given. So net work done is nothing but W1. Just a minute. So W net is equal to W1 plus W2. Okay. So W net he has given it as 2000, that is equal to W1 plus W2. So what we are supposed to calculate in this problem, we need to supposed to calculate what is the torque. So where will be the torque available? So torque will be available where? In the W1, is it? Because W1 is equals to 2 pi nt. Okay, W1 is equals to 2 pi nt. So we need to calculate W1. For that, can I calculate W2, which is nothing but P into dV again? So P into area into change in length. Pressure is given 1.013 into 10 to the power of 5 into area is pi by 4. D is how much? 0.4 whole square into change in length is 0.485. So give me the value of W2 here. Whether W2 is positive or negative. It's positive. Okay, give me the value of W2.
$61.73.
How much?
61.7.
Okay,
No,
51.73.
sir. Sorry, sir. Sorry, it is wrong. Wait, sir.
Okay.
$6.17 into 10 power 3.
6.17
Into 10 power 3.
okay,
Kilojoule.
into 10 power 3 joules. Okay, can I just write it in the joules because your net work done is in joule. So 6170 joules. Is that correct? Okay. Now go with W net calculation, that is equal to W1 plus W2. So you know the value of W2, you know the value of W net. Substitute the things and give me the value of W1. And make sure W net is positive. Value positive how much? 2000, positive 2000, and W1 value is, you have to calculate W1 anyhow, and W2 value, which is work done by the system, is 6170. Now give me the value of W1, which should be negative.
Minus 4.17 into 10 power 3.
Minus 4.17 into 10 power 3. Can I just write it as minus 4170? Yeah. Joules. So it is 41, not, okay. So it is 4173. So you can neglect the Nylac sign because you need to calculate the torque, is it? That's great, Ashwita. Mine 4173 joules. Now, the power of the shafts is given by work done by the shafts divided by time. Okay, just note it down here. So, work done by the shaft is 4173, and the time is how much? 10 minutes. So you have to convert it into seconds. So it is 10 into 60 here. Okay. So the power of the shaft will get it as how much? How much? What is the power of the shaft? So 4173 divided by 10 into 60.
6.95.
6.95
95.
watt. So this would be in watt. So the power of the shafts is given by 2 pi nt divided by 60 in watts. So it is 6.95 watt. Okay, I will just write this. Okay. So from this, what do you need? Torque you need. Torque is equals to 6.95 into 60, okay, divided by 2 pi. What is the value of n? Speed of the shaft, how much, man? 840. So just substitute 840. Now we will get the value of the torque in Newton meters.
-79 into 10 power -3.
79 into 10 to the power of -3. Okay, man. So this is your torque which is required in the problem. Okay. So that's it. This is the reverse of the problem which you have solved previously. There, everything was given. You were supposed to calculate the network output from the system. In this problem, the network output is given. He has asked us to calculate what is the torque input. So we have calculated the torque input. These were the few problems in the frictionless cylinder. So in the next class, which will be the last class for your module 1, where we'll be dealing with the problems spherical balloon. So the problems will be very interesting. A couple of problems are there, followed by your problem which was asked in your previous paper. So 3 problems extra. So that will be completed in the next class. Till then, take care, guys. Have a nice day ahead.